The prisoner's dilemma. Imagine a situation in which two individuals are caught under suspicion for a crime, and they are brought to the police station, and each of them is put in a separate room with their policeman. And the police basically tells them that they don't have enough evidence to convict either of them on the primary charge, but that they have evidence to convict them on a lesser crime. But then the police is offering them a deal. They say, why don't you rat on your partner? And if you rat on your partner, you would come up with a lesser deal. And of course, you can do that, or you could stay quiet. What would you do? Imagine the setup is more like this. You're either the orange player or the blue player. And if both of you rat, each of you gets 2 years in prison. If neither of you rat and you both keep quiet, each of you get 1 year in prison. But if one of you rat and the other one doesn't, the rat gets out scot-free and the person who remained quiet gets 3 years. So if you think about this setup, the optimal outcome is if both people are quiet. The total amount of time in jail is the lowest. But what happens if you don't trust the other person? What would happen if you thought that the other person is likely to rat on you? Now you have an incentive to rat on them as well, and at least cut your own sentence. Well, what actually happens in these situations? Well, the reality is it's a little tough to study prisoners, and it's a little tough to study this particular situation in real life. But we can have lab experiments. And in lab experiments, we can try to simulate these basic circumstances. And the experiment we'll talk about today is by Andreoni and Miller. And they basically gave participants the question of whether to cooperate, take the nice action and be silent, or defect and rat on their partner. And of course, this was run at the university, and it's a little hard to imprison students. So they did it for small amounts of money. And here is the payoffs. If both people rat on each round, they would each get 4 cents. If both people kept quiet, they would each get 7 cents. But if one person rats and one person is remaining silent, the rat would get 12 cents and the person who remains silent would get nothing, the lowest possible payment. And in this experiment, they had 2 separate conditions. They had the partner condition, in which you were randomly matched with somebody else in the lab. You didn't know who it was, but you played with this person 10 games, one after the other. One decision, defect or cooperate. Another decision, defect or cooperate, and so on. 10 decisions. And after those 10 decisions, you switched to a new partner. And again playing 10 decisions, and again switching until people made 200 decisions. 10 games of 10 rounds each. There was also the strange partner condition, the strange condition. And in the strange condition, what happened is that people switched every time. So you never played 2 games with the same person. You switched after each game. One game with one person, another game with another person. You never knew who it was going to be. It was random. And here are the questions for you. What percentage of players cooperate in the first round? And was it different in the 2 conditions? In the condition in which you met a stranger every time, and in the condition in which you played with the same person 10 times? And did the players cooperate more or less as the game continued? If you think about the 10 rounds as the period, is every round getting people to cooperate more or cooperate less? Make your prediction.